It's another math day here with teacher Jenny. Join me for another topic. This time, we're going to talk about derivatives and the activity given to my students. We have k of x equal to 2x squared minus x minus 1 multiplied with the square root of x. There are actually two ways for you to solve the derivative of this one. You may try to distribute that one and then do the derivative of each of the terms as a resulting, or you may go for the product rule. So I'll be showing that two here. So let's start with distributing this one. We'll try to compare the result, whether that will be the same. So again, I'm using the first method here. I'm going to distribute square root of x inside. So this will be now the resulting, the k of x. That will be equal to your 2x squared multiplied with the square root of x. So this will be now 2x squared square root of x. And then this one, we distribute that one here. This will be minus x square root of x. And then we distribute that one here. We have now a negative 1 times square root of x. We have a minus square root of x here. Then we get the derivative individually here, applying our sum and difference of rule on differentiation. So we have k prime x. That will be equal to getting the derivative of this. Since we still have our product here, we can actually combine x and x here. We can transform those that are with radical expression into fractional exponent so that we can add up the exponents here of the common variables. So we can have 2x squared. Rewrite this as x to the power of 1/2 minus x times x to the power of 1/2 minus x to the power of 1/2. Since we were written all those square root of x to x to the power of 1/2, then why not? Now, next one, we are going to get our derivatives. Not yet. We are going to simplify each of the terms here. So this will be now 2x to the power of 2 plus 1/2. This will be now 2 plus 1/2. Because we have the same variable, so we're adding our exponents for the same variable. Here also we have the same variable. So this will be now minus x to the power of 1 plus 1/2. And then we have minus x to the power of 1/2. And then after that one, we can do the derivative. So k prime x of x, that will be now, yes, not yet, because we're not yet done with our simplifying. So we try to simplify that one further. So 2 times x to the power of, we get the LCD. The LCD is 2. So 2, and then we try to simplify that. And then our 2 here is with the denominator, which is 1. So we have 2 divided by 1. That's 2 times our numerator, which is 2. So that's a 4. Plus 2 divided by 2. That's 1 times 1. That's a 1. Minus x. We have the LCD here as 2. Then 1 has a 1 as a denominator. So we have 2 divided by 1. That's 2 times 1. That is 2. Plus, we go to the other fraction. So 2 divided by 2. That's 1 times 1. That's 1. And then copy minus x to the power of 1/2. Simplifying that one further, this is now 2x to the power of 5 over 2. Minus x to the power of 3/2 minus x to the power of 1/2. And then we are now ready to get our derivative for that one. So k prime of x, that will be equal to, we put this down here and multiply that one with constant multiple 2. So this is now 2 times 5 over 2. X to the power of 5 over 2 minus 1 or minus 2 over 2 minus our 3 halves, we can put that down there. So minus 3 halves x to the power of 3 halves minus 1, or 2 over 2. And then we have minus, we bring down 1 half, so we have 1 half x to the power of 1 half minus 2 over 2. So simplifying this one, this is now equal to 2 times 5, that's 10 divided by 2, that's 5. X to the power of 5 minus 2, that's a 3. We copy the denominator 2. Minus 3 halves. X to the power of 3 minus 2, that's 1. And then copy the denominator 2. Minus 1 half. X to the power of 1 minus 2, that's a negative 1. Copy the denominator 2. And then we try to simplify this. So since we have here 5x to the power of 3 halves, wherein our numerator is bigger than our denominator, you can actually separate this one so that you can get those that are whole numbers out from it, because this is improper fraction as a fractional exponent. So we will be converting that one into mixed number so that we can take out the whole number out from the fraction. So basically, this will become now 5x to the power of, this is after getting the derivative of that one. So 5x, 1 plus 1 half. This is similar to 1 plus 1 half. And then we have, why I'm doing this one, because I will be separating those that are radical in format and those that are whole number. And then here we have negative 3 halves x to the power of 1 half. We can actually do it 3 times x to the power of 1 half. That is 3x to the power of 1 half. And then we copy over 2. And then we have minus 1 half. Your x to the power of negative 1 half, we can have it as positive by simply getting the reciprocal of that. So that will be times 1 over x to the power of 1 half. And then we try to simplify this one further. This will be now equal to 5x times x to the power of 1 half. So see, I've separated 1x here with a power of 1 and then x to the power of 1 half, because I'll be rewriting that one into radical form later. And then we have minus 3x to the power of 1 half over 2 minus 1 times 1, that's 1 over 2x to the power of 1 half. So since we've got fractional exponents now, we are going to convert that into radicals. So this is now equal to 5x. X to the power of 1 half, that is equal to square root of x minus 3x to the power of 1 half, that is equal to square root of x. And then we have over 2 minus 1 over 2 square root of x for the x to the power of 1 half. So since we've got a radical expression at the denominator on one term here, we are going to do rationalizing. So this will be now square root of x over square root of x. So we multiply the term here that contains a radical expression with square root of x, so that we can have here on the denominator square root of x squared, and then cancel the square root and the square there. So this is now equal to 5x square root of x minus 3 square root of x over 2 minus 1 times square root of x, that's square root of x, over 2, and then we have the x. So this is now our final answer for the k prime of x using the distributive way for finding the derivative. Now let's go over with the derivative, or the way of using our product rule for getting the derivative of this. So we will be following the format in which we will be renaming one factor here and the other factor with symbols. So I'll be renaming this one as my f and the other one as my g. You can actually make use of any letter there if you want, as long as you are following the format as to how to differentiate that one using the product rule. So according to the product rule, we have k prime of x that will be equivalent to g times f prime plus f times g prime. So what we're actually doing here is that we get one derivative of one factor and the other won't be. And then on the other term, if you've already if you've already differentiated that factor, you cannot differentiate that one again. So you will be differentiating the other factor. So here we'll start off by following with our format. This is now g will copy. We have square root of x for g, so we copy that one. We get the derivative of f, so this will be now 2 times 2, that's a 4. And then x to the power of 2 minus 1, that's a 1. So we don't need to write anything on the exponent part. Minus, our exponent here is 1, so we bring that down. And then we've got x to the power of 1 minus 1, that is with a power of 0. So x to the power of 0 is 1. 1 times 1 is 1. And then we've got a constant. The derivative of that one is a 0. So that will be our derivative of the f. Plus, we have now the f. We copy that one, 2x squared minus x minus 1. And then we are going to get the derivative of the g. Our g there is square root of x. So once we get the derivative of that, we are going to transform that one into fractional exponent. Our square root of x is equal to x to the power of 1/2. So that means to say, once we get the derivative of this, we have to bring down 1/2. So this is going to be multiplied with 1/2 x to the power of 1/2 minus 1. So this will be with 1/2 minus 2 over 2. I'll be writing that down so that it will be easier for you to follow through. And then we have a square root of x here. So I think it's going to be better if we convert that one into a fractional exponent as well, so that we can combine our result on this one here. Or maybe you won't do that one. It's really out to you or your preference, because later on we might find out that there is something that we can combine. So for me, it will be safer for me to convert that one into fractional exponent. So x to the power of 1/2 multiplied with 4x minus 1 plus our 2x squared minus x minus 1 times 1/2. X to the power of 1 minus 2, that's a negative 1. Copy the common denominator. And then that will be equal to, this time I'm going to distribute this. So x to the power of 1/2 times 4x. That will be 4x to the power of 1/2 plus 1, because we have 1 here. That will be equivalent to 2 over 2. And then we have x to the power of 1/2 times negative 1. That will be negative x to the power of 1/2. And then plus, distributing this one here to 2x squared. So 2x squared times 1/2 x to the power of negative 1/2. 2 times 1/2, that's 1. X squared times x to the negative 1/2. That will be x to the power of 2 plus negative 1/2. That will be a minus 1/2 here. And then we have minus x. The minus x or the negative x there, we are going to multiply that to 1/2 x to the power of negative 1/2. This will be now negative 1/2 x to the power of 1 plus negative 1/2. That will be equivalent to negative 1/2. So our one here, we can write that one for easy subtraction or adding as 2 over 2, and then minus 1/2 here. Then we lastly distribute 1 to your 1/2 x, or distribute 1/2 x to the power of negative 1/2 to 1. This will be now negative or minus 1/2 x to the power of negative 1/2. Then we are to simplify. This is now equal to 4x to the power of 1 plus 2, that's 3 over 2. And then minus x to the power of 1/2 plus x to the power of, getting the LCD for this, 2 is with 1. So LCD of that one is 2. 2 divided by 1, that's 2 times 2, that's 4. Minus 2 divided by 2, that's 1 times 1, that is 1. Minus 1/2. X to the power of 2 minus 1, that's 1. Then we copy the denominator, which is 2. And then copying minus 1/2. X to the power of negative 1/2. Then we simplify further. This is now 4x to the power of 3/2 minus x to the power of 1/2 plus x to the power of 4 minus 1, that's 3. Copy over 2. Minus 1/2 x to the power of 1/2 minus 1/2 x to the power of negative 1/2. So we are going to combine like terms. So if you try to look at that, you can find something that is common here between, we're talking about like terms here. That means to say we have the same variable and exponent. So we will be checking that one. This has x to the power of 3/2. This one has x to the power of 3/2. So combining the coefficients here, 4 and 1, 4 plus 1, that is 5. And then we copy the common, x to the power of 3/2. And then we look for more. This one has x to the power of 1/2. Well, this one also has x to the power of 1/2. So we will be combining here negative 1. So I'll be writing that down here. So we've got negative 1 as a coefficient, and then we have a minus 1/2 as the coefficient of x to the power of 1/2. So if we are going to combine those, we have negative 1 minus 1/2. This will be equal to, getting the LCD, and then this has a 1 as a denominator. So 2 divided by 1, that's 2 times negative 1, that's negative 2. And then 2 divided by 2, that's 1 times 1, that's a minus 1. Simplifying, this is negative 3 over 2. Let me write the negative in line with the fractional bar. So negative 3/2. So we copy negative 3/2 here, and then copy x to the power of 1/2. So we're done with those, but we are left with this one here. So we copy that one. And then we are going to now simplify. Simplifying, this would mean that we are going to check for radical or fractional exponents so that we can convert that one into a radical form. So this will be now 5x. Notice that we have an improper fraction on the exponent. So that means to say that we can convert this one into mixed number. Or you can have that one as 1 plus 1/2. Because 1 plus 1/2, that is equal to 3/2. And then we are going to have here minus 3 times x to the power of 1/2. Take note, it has a 1 here as a denominator. So we can just simply multiply 3 times x to the power of 1/2. That will be 3x to the power of 1/2. And then we copy 2 times 1, that's 2. And then we have minus 1/2. Our x is with a power which is negative. We are going to transform that one into a positive power. So we get the reciprocal of this. So that will be 1 over x to the power of 1/2. So 1/2 here, the exponent becomes positive. And then we simplify further. This will be now, we can separate our x here, the one which contains a 1 here and the one that contains a fractional exponent. So 5x times x to the power of 1/2. This is similar to having that as x to the power of 1 plus 1/2. The reason here is for us to have those fractional exponents separated from the whole number, because the fractional exponent can then be transformed into a radical expression. And then minus 3 times x to the power 1/2 over 2. So we copy because we are going to do that one at the same time later on. So 1 times 1, we have 1 over 2 times x to the power 1/2. That will be 2x to the power 1/2. And then we can now transform those fractional exponent into radical. So this will be now 5x. And then this one is square root of x. Then we have minus 3, the x to the power 1/2, that will be a square root of x still. And then over 2, minus 1 over 2 square root of x. Then notice that we have a radical expression at the denominator. That's a no-no. So we go for rationalizing that one by multiplying that with the square root of x, y square root of x, because once you multiply square root of x, this would lead to a square root of x squared. We will be canceling the square root at the denominator part, and so with the squared later on. So that means to say we're eliminating the radical form on the denominator. So this will be now 5x square root of x minus 3 square root of x over 2 minus 1 times square root of x, that will be square root of x, over 2, and the square root of x times square root of x, that would lead to a square root of x squared, so that will be an x already here. So this is now our final answer for our k prime of x. So that is how you do our finding the derivative using the product rule. So go for the video number 3 for more exercises on finding the derivative of a function.